Hello everyone, I am Vishnu. So I am dealing the subject called Power System Operation and Control. So in the last class we have seen about the uncontrolled and controlled cases of operation of steady state analysis, and then we have seen proportional plus integral control of single area system. In that we have seen our static frequency change, that is delta F static is made as a 0. That means we have made delta F static is equal to 0 in that. And then we have seen load sharing between the two generators. So we have seen the load sharing between the two generators, how the load sharing is going to be happens between the two generators we have seen. So in that we have got some equations of load sharing between the two generators. Right. So if we go for the today's lecture, that is the lecture 7. So in that if we go for the learning objectives of this lecture, the first one is to understand the concept of control area. To understand the concept of control area. What is the control area and how it is going to be effects? What are the components of control area? What are the generators are going to be present in that? So how it is going to be, we'll see in that in this lecture. And the next one is to understand the integration of LFC with economic dispatch. So what do you mean by LFC and economic dispatch? LFC is nothing but load frequency control and ED is nothing but economic dispatch. So we are going to integrate both load frequency control and economic dispatch so that we are going to get a proper operation we are going to get. Next one is to understand the two area control concept. What do you mean by two area control? There are two different areas are there. So how we are going to connect those two different areas with a tie line? We are going to connect the two areas with a tie line, that is called as tie line bias control. So that we are going to see in this lecture. Right. So if we see the basic concept of control area. So if we consider in the olden days, we are having the generators. So when the power generation has started, at that particular amount of time, we are having only a single generator. Let us take in the starting, we are having a single generator. For that single generator, we are having a single loads. That is nothing but we are generating the power at particular location where we are having a load. Where we are having a load, particular load. In order to meet that load, we are going to generate the electricity according to that requirement of load. We are generating electricity. We are not transmitting any amount of the power. In those days we are calling that as distributed generators. So wherever the distribution is required, at that particular location we are going to generate the electricity and we are going to distribute to that particular local loads only. So that is what in the olden days happens. But as of now, in the present situation, what happens is the increased demand of electricity, because we are having home appliances. Many home appliances are running with electricity. They are made to run with the electricity or home appliances. So in order to meet the demand, as the demand means as the home appliances utilization is increases means what happens? The demand is going to be increases. As the demand is increases on the generating stations, then what happens? The single generator alone will not be possible to meet that particular amount of load. So for that particular load, in order to meet that load, what we need to do? We need to install the large amount of the generating stations. So another generating stations have started to install in order to meet the load increase. So what happens is we are installing a generating stations where the load is going to be increases. So at that particular loads or particular load centers, we are going to install the generating stations. Either it may be a steam power plant or it may be hydro power plants. Whatever the source of requirement at that particular location, we are going to install. Then what happens is there is no integration of these. There is no connection of these generating stations. That means there is no grid in the olden days. Then what happens if there is any blackout is there, or if there is any problem in any generating station, then that particular load needs to be cut off. That means there is a power cut to that particular loads. So in order to overcome those power cuts, what we need to do is we need to interconnect the total generating stations with a grid. So that is called interconnection of all the generating stations together, called as a power grid. So for that grid we are connecting all the generating stations, so that if there is any disturbance in any particular generating station, if there is any blackout or any overhauling, any problem is there in a generating station, so we can meet this load by increasing the other generating station generation. That means the power generation is going to be increases. So if you see here, you are having high voltage, so there you are having high voltage generating stations. It may be a nuclear power plant, it may be a steam power plant, it may be a hydro power plant, whatever it may be. There are different power plants are there. You are generating the power with high voltage. That high voltage is connected to the grid. And then you are having here low generation of power. So there are two industrial loads, or industrial generation is there, and there is other generation there. So these low amount of voltage generation or low amount of the power generation which is connected to the transmission network directly. So there you are having high voltage, and you are step up that voltage, and then you are having a transmission network. So that transmission network, these generating station, industrial generation and other generation are connected to that. Then you are having distributed grid, that is nothing but distribution grid. You are connecting this to distribution grid. So for that distribution grid you are having loads, many loads are connected this side, and that side you are having generation. Some generation is done by the wind power plants and some generation is done by the solar plants. So this is what all the interconnected networks are going to be connected together, so that if there is any drawbacks or any blackout is there in any generating station, if there is any problem in the generating station, then you need to increase the other generating station generation. Then that whatever the load is there on that blackout power station will meet by the other generating stations which are available in the grid connection. We are going to control it. That means in order to meet that load, we are using interconnected grid. So that is, if we come for the basic concept of control area, in that if we see that there are load dispatch centers are going to be present. If we come for India, so in that India you are having different load dispatch centers. If you consider, as I said, that there is an interconnection of grid. So there is an interconnection of grid. So that grids are going to be classified as, there is a, if you consider the nation, there is a national grid, and there is a state level grid, there is a regional grids also. So these grids are classified as different stages. The first one is national grid. So for one nation you are going to have single national grid. So then you are having regional grids. So regional grids are nothing but, if you come for India, so in that you are having National Load Dispatch Center, which is available in the Delhi, and there is a other regional load dispatch centers. Regional grids are going to be present. So for that regional grids, you need to connect to the regional load dispatch centers, LDC, regional load dispatch centers. So if you come for northern states, and then you are having western states, and you are having southern states, and then you are having western states. So all these are having different load dispatch centers. If we come for southern states, so in the Bangalore it is there, Southern Load Dispatch Center. Southern Load Dispatch Center is there in the Bangalore. So from that, the total region, that is southern region, is going to be totally controlled by the Southern Load Dispatch Center. That is what the regional load dispatch center. From that particular location, we can control all the loads, as well as all the generators which are connected to that is going to be controlled from that particular location only. We can control directly from the Bangalore. We can control the total southern states generation is going to be controlled, as well as the southern state load is going to be controlled. So that is what your national load dispatch centers. Then if I come for control area, what is actually the control area? Control area is nothing but, it is an area where all the generators are connected together, and all the generators are going to be operate simultaneously. That is what we are calling as coherent operation of generators. That means if there is any change in the load, that according to that change in the load, all the generators are going to be changed their setting of speed governor. That is what we call as steam valve. The steam valve is going to be changes according to meet that particular amount of load. So if I consider some area, whatever the generators are going to be present in that area. So if there is any load change is available in that area, then what happens? That whatever the generators which are present in that area is going to be changes their setting by changing the steam valve input. That means all the generators it is an area where all the generators are running coherently. That is, they run simultaneously. That is known as control area. Next, we are going to see the integration of load frequency control with economic dispatch control. Integration of load frequency control with dispatch control or economic dispatch control it is. So if we see the economic dispatch control, what is the need of integration of this load frequency control with the economic dispatch control? So if we see the load frequency control, we are using an integral controller. So if you see the integral control is there, so that integral controller, that is minus ki by s is there. So that by using of integral controller, we can reduce the steady state error in the frequency is makes as a 0. And you are having particular dynamic control of this. There is a dynamic response, that is a fast dynamic response is going to be how? Because of the use of integral controller. Because of the use of the integral controller, we are having fast response of the dynamic response. So we are having fast response, but we are not having any control over the allocation of the load change. So if you are having the load change is there on the any power station. So let us take, there are power station. So that power station, there is a load is there. So according to that load, whatever the change is there in the load, so according to that load, there are generating station is there. In that generating station, you are having different generators. You are having different generating units. So which generating unit needs to increase the generation? There is no control. There is no control over the generators. For which generator we need to increase the load demand. So in order to achieve that particular generation and demand, meeting the demand process, what we are doing is we are integrating the economic dispatch control with the load frequency control. We are integrating the economic load dispatch control with load frequency control. So that what happens, economic dispatch control is nothing but EDC. EDC is a generation of electricity or generation of the power with economical considerations. What we are doing is, economical consideration means where you are going to have or where you are having availability of generation of power with low cost. By reducing the cost, where you are having, in which generator you are having low cost generation. For that generator, what we are doing is we are increasing the generation for that particular generator, so that up to maximum load, how much we can apply the load on that particular generation, we are going to increase the generation of that particular generator where we are going to get the low amount of the cost. So for that we are increasing the generation. So what happens means we can get the electricity with low cost. So for that purpose we are using economic dispatch control. So that's why we are integrating this load frequency control with economic dispatch control. So what happens is there is a power system control area. So that power system control area needs to be controlled. So if there is any change in that power system control area, then what happens means that change in the load demand is going to be controlled. That change in the load demand is going to be controlled through the load dispatch centers. We are having local load dispatch centers, that is local EDC, local economic dispatch controller, local economic dispatch controller. There are two areas we are considering here. The first one is first controller and second one is other controller, which are connected together. That means there are two generators are going to be there. So these two generators, first one is a one generating controller, the other one is the other generator controller. There are two generators are going to be used in order to meet that particular amount of the load. So there is a power system control area. So in order to control that, we are having two generating stations. So with two generating controllers, that is speed governor, turbine, and all those things are there. So what happens is, if there is any change in the load in the particular area, then what happens? That signal is going to be sent to the local economic dispatch controller, which is available at the central level. That is nothing but central economic dispatch computer. So there we are going to record the change in the power. So this change in the load demand or change in the power demand, which is registered at the central economic dispatch computer. So from that we are going to get the signal to the local economic dispatch controller. Right? Local economic dispatch controller, you are going to get the signal from that central economic dispatch computer. So this central economic dispatch computer is available at the state load dispatch centers, SLDC. That is what we are calling as SLDC, state load dispatch center. So from that state load dispatch center, that is at the central level. If we come for Telangana state, in the Telangana state we are having state load dispatch center at Hyderabad. So that is the central location at that Hyderabad. From that location we are having the controlling. That means there is a computer is there. So there is a total setting is there in order to control the total load of the electricity. So from that center we are going to control the electricity. So what happens is, if there is a change in the power demand, that is going to be get the signal as a power generation command. So here what happens is, you need to increase the power generation. There is an actual value, there is a difference value. The actual value of the power generated is going to be coming from that generator, and the reference value where you need to increase the power generated. So that is getting the signal from the Central Economic Dispatch Computer, CEDC, Central Economic Dispatch Computer. So from that CEDC you are going to get the PG reference value. So that reference value is compared to the P actual value. Then how much it needs to increase is going to be set by the PG referred value, right? So PG actual and PG reference value both are going to be compared each other. Then that gives a signal to the speed changer in order to increase. Both the speed changes it is given the signal. So that the speed changer setting is going to be changes. Then what happens? That speed changer setting is going to be changes the speed of the turbine. Then the speed of the generator is going to be changes. Then the generation is going to be increases. When these PG actual and PG reference values both are equal to same, then the error signal is going to be makes 0. Then you are not having any again speed changer setting. There is no speed changer setting is required when PG actual and PG reference values both are same. So that signals which we are getting from the central economic dispatch computer to the local economic dispatch controller. So from that local economic dispatch controller only it is controlling the total generation in that particular area. In that particular area it is going to be controls. So that is what the integration of load frequency control with economic dispatch controller. So that load here you are having local economic dispatch controller. So that economic dispatch controller, whatever there in the local side, so that is the main controller. So for which generator we need to increase the generation, which generator is having the low cost of generation. The data is available with the local economic dispatch controller. So what happens is that local economic dispatch controller is going to be controls, and then for which generator we need to increase the demand, so that we increase the generation, from which we need to decrease the generation. If the lower one is having the highest cost of generation, for this lower one generation is going to be decreased, the upper one generation is going to be maximum load is going to be connected. So that is what the integration of load frequency control with economic dispatch control. The next one is two area system. If we go for the next concept is two area system. So till now we have considered only single area system, but we are going the integration of two single area systems. We are interconnecting the single two area systems. Single areas, one control area, another control area. We are going to connect these two with a tie line. In order to have the power transfer between these two areas, we are going to use a tie line. With a tie line, we are going to connect these two areas. There is a tie line bias control. Let us consider in the below figure, that is tie line bias control. So in that we are having two generators, that is S1 and S2. That two generators are having individual loads, that is load at the S1 and load at the S2. These two generators are connected with the tie line. The middle one is called as tie line, which is used to transfer the power from one generating station to the other generating station. That is what we are tie line bias control. So if we go for the important concepts of these tie line bias control, that is two area system, there are three important concepts we need to understand in order to have the controlling of the two area system. So in that we are having flat frequency control, that is flat frequency regulation. What do you mean by flat frequency regulation? If you see that flat frequency regulation, you are having two generators, that is S1 and S2. If the change in the load of any one of these two, that is either it may be S1 or it may be S2. If the generation of one is only alone, so if you see, so in this you are having two generators S1 and S2. If the generation of this one only alone changes, because of the change in the load, either it may be the change in the load, it may be in the S1 load or it may be in the S2 load. Whatever the load is going to be changes. According to that change in the load, only S1 is going to be adjusted. That means S1 is only increase the power generation. Such a control, in order to maintain the frequency constant, such a control or such a regulation is called as flat frequency regulation. If change in the load is either S1 or S2, and if a regulation is S1 alone is regulated, if the generation of the S1 is only regulated to adjust the change in the speed, so has to have the constant frequency. This method of regulation is known as flat frequency regulation. Next one is parallel frequency regulation. What do you mean by parallel frequency regulation? So here the parallel frequency regulation is nothing but the sharing of the load is between the two generators. Simultaneously, both the generators are going to be changes. That means, in order to meet the demand, if there is a demand change, there is power demand change, there is a load demand changes, what happens means, in order to meet that change in the load, then the two generators simultaneously operates, simultaneously regulates. But in the previous case, what happens, only one generator alone handles that change in the load in the two generators. But whereas if you come for parallel frequency regulation, both the generators are going to be change the generation in order to meet the load by maintaining the constant frequency. This is known as parallel frequency regulation. The last one is flat tie line loading control. Flat tie line loading control. Flat tie line loading control is nothing but what? Here the possibility of change of particular area is taken care of by that particular generator. So let us take there are two areas. You are having two generators. If you see here, you are having two generators. So if there is any change in this load of the generator 1, that is S1, if there is any load change, that generator generation is going to be changes only. That is S1 generation is only changes. If you are having any change in that S2 generation as well as S2 load, that S2 generation is only changes. There is no interconnection of these two. Right. So that is known as the last one, that is called as flat tie line loading control. Right. So if we see the summary of this, then what we have learned is we have integrated economic dispatch controller with load frequency control. So that what happens is the power system is going to be integrated with the economical operation. We can control the power system with economical operation. To have the more power to meet the generation and to meet the load, to meet this generation to load, so this two area system will helpful to integrate the load frequency control. Right. So two area system we have tie line This tie line is used for what? In order to transfer the power from one generating station to the other generating station. In order to transfer the power between the two generating stations or between the two areas, we are using tie line. Right. So we have learned, first we have learned single area system, then we have learned two area system. So then this will helpful for the calculation of, for the integration of grid connection. We are going to use an interconnected grid system. So in order to analyze that grid, we are going to use this two area systems, which is very helpful. So thank you everyone. Thank you for listening.